Okay, so now in this example we have two pulleys with a belt. Now the belt is 10 feet long, and it takes the belt to make one revolution. So if we were to pick a point and mark a point on the belt, it would take 2 seconds for the point to come all, the mark to come all the way full trip. Okay, so what we want to find out is, based on this information, so we've got a pulley that is 6 inches with a 6-inch radius. Now, yeah, let's just set it up here. So we got a 10-foot belt that goes around 2 pulleys, and we've got, the pulleys are each 6 inches with a 6-inch radius. Okay, and it takes 2 seconds for the belt to make one complete revolution around the pulleys. Okay, now so let's look at the linear speed, v. Okay, let's look at the linear speed, v. Okay. Now in this case here, because the belt, again, assuming this is a nice snug belt, no slipping, the belt is moving at the same speed as the point, right? So if it takes one point to go 2 seconds around, one revolution, right? So it takes 2 seconds, and there's 10 feet. So basically it's traveling 10 feet in 2 seconds. So the easy one is linear velocity is just, well, it's going 10 feet over in 2 seconds. Okay, so that means it's going what? 5 feet per second. Okay, now the radius of the pulley is 6 inches. So let's change this, because we've got feet here. So the radius R of the pulley is 6 inches, but let's write that as 0.500. So actually, let's write this as, just to keep the unit, or the significant digits the same. So 0.500 feet. Okay, so I'm just converting it to feet to keep the units matching. Now, we can find the angular velocity by just substituting, right? So we know that v is equal to omega r. So now we can just substitute this in and say, okay, this is going to be 5.00 equals omega times 0.500 and so omega is equal to, or the angular velocity is equal to 5.00 divided by 0.500, okay, which in this case is going to be 10.0, and that's radians per second. Okay, now let's change this to revolutions per minute. Okay, since that's more of how we do this. Okay, so now what we want to do is, well, we want radians per minute. So again, we're just going to convert this. So we need revolutions. So first of all, I'm going to multiply by the unit ratio that to change radians to revolutions. So I know that 1 one revolution is equal to 2 pi radians. So the radians will cancel with that. Okay, so now I've got revolutions on top, which is what I want. Now I want minutes on the bottom. Well, I know that, and I've got seconds on the bottom here, so I need seconds on top. So I know 60 seconds is equal to 1 minute, right? And so seconds is going to cancel with seconds, and so now I got revolutions per minute. And so now all I have to do is multiply and divide, and I get 95.5 revolutions per minute. And that's it. Have a great day.